Hello, this is truly the last part of C3 now. In the last video we did the start of numerical methods. So that was solving equations by graphing and showing if there's one or two solutions to the equation. And what we did in that, if you cast your minds back, is we split the equation up into two parts, and then we drew them two graphs of y equals the first half and then y equals the second half. And if there was two intersections or two solutions, etc., it goes on. So what we're going to do in this C3 video, now there are two separate topics I'm going to combine into one video because I'm quite lazy and I can't bother to do two separate videos. Well, it's not that, it's really, the first one is too short and I think it should be a topic on its, a subtopic on its own, to be honest. I think it should be combined with this this other one. Anyway, so the first part of what we're going to do is a smaller section, proving that there is a solution when it crosses through the x-axis, or when the solution crosses through, and finding the points where it does. And then we use the irritive formula to sort of narrow it down, essentially. So that's why I think it's quite a good idea, because the first one is sort of more broadly what you'd expect to prove it, and then the irritive formula narrows it down, so that's why I've combined them into one as well. Just decided then. So, okay, so say you've got a graph that looks like this. Now I'm going to draw the small, sort of the outward appearance of the graph on this graph here, and then I'm going to draw another graph in a large section, essentially. So imagine we've got a graph that looks like this. A quadratic is probably the best example of this, actually. If we do something like that, now that is probably going to have the equation. I'm just guessing here. It's going to be like x squared minus 4 or something like that. That could be a possible equation of the graph. And then obviously you'd know if that was x squared take 4, you could work out the intercepts of that, which should be, so that'd be minus 4, and then you've got your two intercepts here. So if we wanted to, obviously you should know what they are, but if we didn't know what they were and we wanted to work out what they were, we could make a reasonable guess. Say that the equation was much harder than x squared take 4. Say it was x squared, x plus 2 squared take 3 plus 2, and go on, etc. Obviously you'd simplify it down first, but just say for example it was a bit harder and we wouldn't know what it was, and you wanted to find what the x-intercepts were. Obviously you know the y-intercept is -4 from this one, so it's quite hard to try and find that any other way. Okay, so see if we had a reasonable guess. Okay, so if I enlarge this section, so the right hand side of the graph is the part I'm going to enlarge. So say we had a reasonable idea, say we knew it was between 1 and 5, and then to say prove x is between 1 and 5. So we do put x is 1 into this equation, so f of 1, and that would be f of 1 squared, take 4, 1 squared is 1, take 4 is minus 3. So that shows that when x is 1, y is minus 3. That's simple C1 stuff. And then we said at 5, prove it goes above the x-axis, so 5, so we put f of 5, so 5 squared, 25, take 4 equals 21. So therefore, because there is a change of sign, this is what this part's actually called, a change of sign. You go, because there was a change of sign between f of 5, sorry, and f of 1, because that tells us our y value, remember, so when y value is positive, it's obviously above the x-axis. So when f is 1, x is 1, the curve is below the x-axis, so y is negative, but it goes above the x-axis when there's a change of sign, hence at f5 it's positive 21 as opposed to f being -3 at 1. Okay, so that's why I didn't spend too long on that part of the equation. Obviously you could find out what x is and work it out from there. Okay, but at least we've shown it's between 1 and 5. Obviously your equations in C3 are probably going to be a little bit, will be a lot that was sort of an idea to understand why, how it works essentially. So say we had that equation. Now I'm going to use my book, one sec, just to give you an example. So if I try and make one of that, I'll get it wrong, and I'll end up doing when we're doing with this. So one sec, let me just find an example here, and I'll be able to use it to show you what the next part is, which is the irritive formula, or as I call it, irritating formula. Now, generally, a key thing to remember in this is they generally give you the formula. But if you were asked to find it, or if you weren't told it, and you just said, find what the root of x is, or where it intercepts the x-axis, that's what it essentially means. Sorry, one sec, let me... There's not any good examples in there. So I'll just pause the video for me. Obviously you carry on. But I'm just going to find an example. I'll be back in a minute. Right, okay, found a good example here. Alright, so say we've got the equation x cubed take 3x plus 1 equals 0. And now if you wanted to factorise this and simplify it down, obviously you'd end up looking something like this. So you go x, you go y. I mean, I'm not sure exactly where the intercepts would be. As I said, I haven't really done this, but it'd probably look something like that, I would have imagined. So that'd be, so that would call it f. That's just a, obviously that might be completely incorrect, but it's going to have some kind of dip in it. So it'd be basically some kind of x cubed graph is what I was going to try to show there. So that's what that is essentially. It's going to look like something like that. It might not be exactly the same as that. It might be a bit taller, or this might not go underneath the x-axis, but it's going to look something like that. So hopefully that helps you understand what this graph should look like. Okay, so if we wanted to sorry, one sec. Yeah, obviously, sorry, that wasn't quite right. It's sort of an x cubed graph, but it will look something like that. So if we had to find the irritive formula of this, what would we do? Well, the first thing you need to do is choose an x value. So we're either going to use x cubed or minus 3x, or 3x, sorry, as the subject of the equation, because we've got to make an x the subject of the equation, because at the moment 0 is the subject of an equation. That doesn't help us at all. So the easiest one out of them to choose is the 3x, because then otherwise we'd end up cube rooting it, and I'll explain why in a minute. So add the 3x to this side, so 3x equals x cubed plus 1, okay? Now that still doesn't give us 3x x as a subject of the equation, it gives us 3x. So what we need to do is divide both sides by 3. So x equals, now the way you could do this is, instead of going x plus 1 over 3, you could simply do 1/3 brackets x cubed plus 1. Now you could do this for any equation, but as long as you get we could have done x cubed, but obviously that would have meant just get x, and so we would have had to cube root 3x take 1, which might have been a little bit more difficult. A bit more, well, it wouldn't have been that much more difficult, but it wouldn't have, more likely to make a mistake is what I'm trying to say, okay? So this looks like some kind of formula, doesn't it? It looks relatively x equals 1/3 of x cubed plus 1. It does look fairly, something like a formula. It almost looks like y equals mx plus c, which essentially is what it is. We've just got x in two places there, if this is making any sense. So hopefully I've explained why that you could solve. If you got to this point and you thought, okay, what do I need to do next? That looks like some kind of formula. And x is going to be some kind of term. If that's what we're trying to find. We're trying to find a root of some kind. So how can we make that as into a root? Well, if you cast your minds back to arithmetic progressions, I think it was, we sort of had something like, I can't remember exactly what the formula was, but we had one term and then the previous term, and we did something to it. So we either times it by 3 and added 1, or we times it by 2 and added 6, or square rooted it or whatnot. This is the same sort of principle as that, but we're not just simply finding the next term like we were in C1. What we're essentially doing in this in C3 is we're trying to find the roots. So I'll explain how we do that in a minute, but this part here, what I'm going to do next, looks exactly the same as your C1. So x of n plus 1 equals a third of x cubed subscript n plus 1. Okay, so what does this tell us? Well, that looks like the arithmetic progression of C1. That's where we had one term and then a third times the previous term plus 1. Yeah, so that looks something like that. And we could do, what they'll generally give you is say x0 equals 2, for example. And it'll say find the roots of the equation 2, and it'll say a set amount of decimal places, and that is very important, because when we put x is 2 into the equation, what we're actually saying is this n here, so we've got n plus 1, what we're saying is that n is essentially 0, because what we've got is x subscript 0, and we need to put x subscript 0 into this bit. So x subscript 0 is the same as x to the subscript n is the same as x to subscript 0 for n equals 0, because we're just simply putting n is equal to 0 into this equation. So that's going to say x1, which is the next term after x0. That's saying the next term is a third times the previous term cubed plus 1. So if we do that, I'm going to show you a cheating way to do this as well in a minute. So a third x cubed, x0 cubed, which is 2 cubed, which is, I'm just going to write 2 cubed, but obviously you know that's 8 plus 1. 8 plus 1 is 9 times a third, 3, so x to the 1 equals 3. Just make sure I've not gone completely balmy. Sorry, just making sure I've not gone totally insane and can't do simple maths. Just make sure you know you can do the simple stuff. So 2 cubed is 8 plus 1. Yeah, that's 3. So x1 I wasn't going mad for a second. X1 is 3. Okay, so what happens if we were to keep putting the previous term and keep doing this step over and over again? Well, we'd have about 25 lines of working out, wouldn't we? So if we're saying the question would say something like x cubed, take 3x plus 1, find the root of the equation that is between was it? Yeah, because essentially what we did there was split it up to 2 equations. So sorry, should have drawn that. So it looked like something like x cubed plus 1. It's going to intersect 3 times. Okay? So that's, I should have drawn the graph method first. Okay? And it says x is between 0, find x is between x is 0 and minus 2. That should be the other way around, really. I think, yeah, so then what we'd do is we'd keep putting the next term into the equation here until we came to a point where it said to 3 decimal places. So what we'd do then, just double checking my work, it's like crazy. Alright, okay, so what we need to do is, we could write 25 lines of working out, but that's quite lazy. Mathematicians are generally, so there's quite a lot of working out and requires a bit of effort, and mathematicians are quite lazy, like to find cheating ways to do things. So, first thing you need to do is put your first term that you're given, so x equals to 2, into your calculator. And then you press your equals button, it registers it in the calculator, as the answer. So if you press the answer button, it should come up as 2. So that in the calculator's memory, we've got the answer equals 2. So that's ANS. That's why I like to think of it as, even though it doesn't spell answer. Obviously for the English people out there, that we just use it in our head. And then we simply put the equation here, substitute it in. Obviously, don't put x plus x subscript n plus 1 because we don't know. That's what we're trying to find out by pressing equals. So we put the rest of the equation in. So if we set it out like we did on the board, so it's a third, and then we open the brackets, and then we put in our old equation, so the ANS, and don't forget it's cubed, so we have to put cubed, and then it's well, add in 1, and that gets us 3, which is our next equation. Okay, so we know that formula in there is right. So if we press it again, what we're doing is we're putting x is 3 into that equation, because the answer one changes consistently with regards to what you put into it. Okay, so then that's the next one, 9.3. The one after that, 271.34. So then keep going until we got to a certain amount of decimal places. Sorry, I'm sorry. So make sure I'm doing that right. I don't know what's going on with my calculator. Let me try a different calculator. Because on my sheet here it says x1 should be 0.5, which seems more realistic than 3. Sorry, I just pause the video and I'll try and work out what's going wrong. That should be 0.5, one sec. Sorry, yes, that'd be right. I just used x subscript 0 as 2 and that was incorrect, but just assume it gave you that. And you'd keep doing that formula until, so that 0.5 was for a different starting value of x. That's why I got confused. But if you kept pressing 0, you'd get onto a certain number, and when that number was constant for the number of decimal places, so if it was 3.99 for example, and you wanted it to 2 decimal places, and then the third one kept changing, and then when that stayed the same, then the fourth one would start. They'd all be changing, but it'd start to slow down. So first of all, the first decimal place, that number would stay the same. Then it'd be the second. Then it'd be the third, and it'd keep going until it sort of stopped, and it looked the same on your calculator. That's because your calculator can only register to X amount of decimal places. And if you kept going beyond that, the number would still be changing behind the scenes, but it wouldn't be able to register it on the calculator because it'd be too big for the screen. So essentially, that's why if you kept pressing X there, you'd end up with the same number. Now the problem with doing it starting with 2 is what I had a bit of a problem with. The number got so big in the end, it was pointless because it came to a math error and it wouldn't. That's just because the calculator can't function it out. But if we started with X's, generally what they'll do is they'll give you a value, x0, that could be any value, that's your starting value, and you just go on between them, changing your values as you go along. So hopefully that makes some kind of sense. If it didn't, I do apologise, but I'll see if we can just have a look now, see if there's any exercises that we could do. Alright, okay, I think this would be a good one. So if you're in my class, then good luck. Turn to exercise 8.3. This is question 1. Now I'm just going to do question 1 because I don't want to dwell too long on this, as it's a bit of a faff really. Because once you get the idea of it, I didn't explain it very well because I used the wrong starting value of x. Can't believe I did that. But yeah, so as long as you get the method. The first part, remember, was really simple. It was just about going through the x-axis, and this is narrowing it down. So it says, draw a rough sketch to show that the equation x squared plus 1 equals 2 cos x has two solutions which are symmetrically positioned around the y-axis. So obviously what we need to do is it's already split up the equation for us. So what we've got is we've got y equals x squared plus 1 and y equals 2 cos x. And if we assume that on the left x squared equals fx, is fx close brackets plus 1, and that's 2fx, because cos x equals fx. That's what we're assuming in terms of the original equation of the graph. This allows us to go back to our C1 stuff and say, well, what's actually happened to the graph? So the graph of cos x has been stretched parallel to the y-axis with a scale factor of 2. So essentially all the y values are times by 2, both positive and negative. The x squared plus 1 graph, the x squared graph has been translated 1 unit up. That's all you need to know. Okay, so to be able to draw this graph, so if we draw it on the same axis, so the most common problem with people drawing cos graphs and sine graphs is they don't know where to start them. They say, oh, does it start at 1 or does it start at 0? Obviously in this case it'd either be starting at 0 or 2. So what we do is we put cos or sine, whatever curve you're using, cos of, in this case cos of 0, because that's what the y-axis starts from, obviously. So cos of 0, and that tells you cos of 0 is 1. So you know the graph starts at 1, and it takes 2 pi to go one whole cycle. So that's down and back up again. And obviously pi to do half a cycle. Yeah, so 360 degrees equals 2 pi, 180 equals pi, 90 equals a half pi, etc. So, obviously this is telling that means I should have mentioned this is in radians. But for the moment, that's not really, we're not really interested in that for 1a. So this is 1a, by the way, which says, draw a rough sketch to show the equation has two solutions which are symmetry positioned around the x-axis. So solutions where you intersect. So if it's easy to draw the 2 cos x graph, do that first. So if we do, oh yes, symmetry position, sorry, I just assumed you'd know this, which is sometimes a bit thingy. Symmetry position is just different, the same lengths or distances on either side of the y-axis, and that's obviously going to be the same because cos x, the x squared plus 1 graph is simply just moved up one. It's still symmetrical on either side, so whenever it intersects on one side, it's going to intersect on the other at the same point. So remember we said it starts at 2 because 2 times 1 is 2, so it's going to look something like this. Obviously this isn't the best drawing of a cos graph because the top half done the same. So that's a bit much on that side, isn't it? Yeah, okay. Obviously I could keep going on with this graph, but just for your sake I'll just make it simple, easy on each side. So x squared plus 1, so it's just the x squared graph moves up 1. So it sort of goes like that through 1. And these 2 points where, apart from my terrible drawing, they should be exactly the same. They should be just mirrored across. So it'd be there. See, I'll just redraw this because it doesn't look perfect. So look, hopefully you can see that them 2 points, there and there, are positioned in exactly the same point on either side of the x-axis. So you could just, y-axis, sorry, you could just say that just proves it. And he did say rough sketch, so the reason why it says rough sketch and not just sketch is they're not asking you to do it with, you know, it doesn't mean rough sketches in the sense it's just scruffy. It just means you don't have to put the coordinates on there, which, you know, would have taken a bit of time, to be honest. And I think that's because it's going to ask us. So I'm just going to draw sort of the same thing again. Obviously these should all be the same height, but my drawing is really bad because I'm trying to get through it a little bit more quickly today. So hopefully that is just, that graph is there, is just what we had over here, but I've just made it smaller so we can keep it on the board. So that's 1A, so that would be, if you got that, would be right. And it show that the positive solution lies in the interval 0.7 A, 0.8. So using what we said before about making X the subject, and using the irritive formula, coming up with an irritive formula, and narrowing it down, try and use that irritive formula to solve that question. And I'm just going to check my answers while you're doing that. So just give you a minute to pause the video now, and we can come back to the answer in a minute. Sorry, I know you probably had a go at this question. I'll have that 1B there. But if you haven't already, I'd just like to stop a minute. The question sort of, it's not asking for the irritive formula just yet. I don't know, I get that wrong. Sake. What it's asking for is just prove that it's between them two. So it's actually the change of sign method. So hopefully that helps. Right, sorry if you made that mess up there. I'm assuming that was my fault. If you did, you can blame it on me. I'm sure you'd want to if you did. So we're saying prove it's between them two. So what we do is we put this all into one equation. So it equals 0. So instead of x squared plus 1 equals 2 cos x, it's x squared plus 1, take 2 cos x equals 0. Okay, so what we need to do is we need to put f of 0.7 in, and that gets us 0.7 squared plus 1, take 2 cos 0.7. Don't forget to put your calculator, I should have mentioned again, but I did mention before, it's in radians. So put that in your calculator, so 0.7 squared plus 1, take 2. Oh, we need to change the setup. Sorry, one sec. If you're not sure how to change the setup on your calculator, you shift mode and you get a set of options, and number 4, radians. That's for my calculator. Might be different for yours, so you need to look up how to change it. So 0.7 squared plus 1, take 2 cos 0.7, that should get you negative 0.039. Just double check what it says in my calculator, in my answers even. Yep, and we put f of 0.8 in, do the same thing, 0.8 squared plus 1, hold that, put plus 2 there, plus 1, take 2 cos 0.8, and if you put that into calculator, you get a positive figure, and then you just say, because there's a change of sign, that proves that there's an intersection between f of 0 and f 0.7 and f of 0.8. I mean, I should have got that from the question, really, to be honest, because it says, the question says, show that the positive solution lies. It didn't say find the positive solution, that's what I was reading. So that's a key point there, actually, by making that mistake. Hopefully you've seen that. That you need to properly read the questions. I sometimes don't. Okay, so 1C, that was the next part, and it says, find and apply the suitable irritive formula to that equation to find x1, x2 and x3. So simply what we do for this is we put x, I'm going to choose x squared as a formula, so x squared equals 2 cos x, take 1, just move the 1 to the other side, because that's an x squared, we square root x squared to get x, and then that equals square root 2 cos x, take 1, So x equals the square root of 2 cos x, take 1. And obviously that isn't iterative formula just yet. You need to put xn plus 1 equals square root of 2 cos x subscript n, take 1. And then we simply substitute our values in, and it says x0 equals 0.7. And then we simply substitute n equals 0 in, so that x1 equals the square root of 2 cos x, or 2 cos 0.7, sorry, take 1. And that gives you an x1 value .728, and you put that in, do that again for x2 and x3. If you want to go with that, just give you a few seconds to have a go. So you just put x1 into that formula and then x3. Okay. Okay, so hopefully you've had a go. X2 is 0.702 to 3 decimal places, and then x3 equals 0.726. And if you wanted to find the root of that, because we know it's somewhere between 0.7 and 0.8, you'd keep putting this in until you got a steady value to how many ever decimal places it asked you to find it. But it's likely to be 0.72 something, because that's the way the formula is going. Okay, so that's 1A, 1B, 1C for exercise 8.3. I'm not going to go into too much more detail because I think that's fairly simple sort of thing. The hardest bit is knowing what formula to use and how to sort it out and put it into the correct formula. Okay, so again, just if there's got any queries or anything.